tools developers, team leads, directors, designers, creators. Today, I'd like to share how at Playground Games we improve the stability of our toolset and increase developer confidence by adopting a test-driven approach to tools development. I'm going to take you on our journey from zero to over 1,000 automated tools tests during the development of the Forza Horizon 4 expansion packs, Forza Horizon 4 Fortune Island, and Forza Horizon 4 LEGO Speed Champions. By the end of this talk, you will see how a test-driven culture has increased our developer confidence, reduced bugs, and improved collaboration. You'll know how to help your teams cultivate a culture of testing when approaching tools development, and some pitfalls to avoid. My name is David Paris. I'm a senior tools engineer at Playground Games and chairman of their testing working group. I've been at the studio for just under 2 years, and before that, I spent a number of years in the fintech industry building highly scalable and reliable systems. I'll begin today by describing what a test-driven culture meant to us and why we thought it was important. Next, I'll focus on the steps that we took to cultivate a test-driven culture and what we learned. This journey enabled a tools developer to spend 20% more time adding new features instead of fixing bugs over a 5-month development cycle. After that, we'll talk about Playground Games' plans to expand their approach to the entire studio, and we will end with a summary of the key points that you can take back and implement within your own teams. So content creators and developers rely on our tools to create the games that they want to create. They rely on our tools to be transparent, to not get in the way of the ideas that they have. When our tools don't work, our users can't work. So during production of Forza Horizon 4, we aim to release a manually tested set of tools every 3 weeks or so. Unfortunately, because of the load, manual tests took over a week to complete, and context switching back and forth between bugs and features made it time-consuming to resolve issues. Our release tools would still have bugs in areas that should be working, and our users were frustrated. Us tools developers were frustrated, and we wanted to change that. What we wanted was a culture where developers, stakeholders, and users feel confident that tool changes work and retain stability without hindering creativity and iteration. That is our test-driven culture. Stability isn't a problem limited to the games industry. It's a problem that all software development teams face. So we looked at other industries, and the answer that kept coming up again and again was automated testing. Now, there already was a push on the game's runtime side, and we had invested heavily in the tech to do testing, but did not understand the time required to get teams on board, meaning adoption was slow. So how were we going to introduce it into our toolset during a development cycle when our team was already felt overburdened with bugs? One thing we did know was that any culture shift would not be something that we could change overnight. Remember this when you are back at your studios. A culture shift is very similar to making a game. It requires lots of mistakes, iteration, and evaluation to get right. Our first step was to raise awareness about automated testing, understand why it hadn't been adopted studio-wide and what the concerns were. Dialogue is crucial. If people are talking or hearing about a topic, then they are subconsciously thinking about it. It's the same reason advertising works. Through dialogue, we learned that there were a number of worries. The first was, how do we automate tests for systems that weren't designed with testing in mind? The second was that we don't have time to test. Now, worries might sound negative, but we thought they were great, because to us, it meant that people were engaged. Reading about testing is very different to seeing. So, we went for it. After raising awareness, we decided to write unit tests during the development of our expansion packs. We chose unit tests because of the vast amounts of helpful resources available online, because we thought it would be the most straightforward to adopt. We took a hands-on approach by writing tests for a small, standalone library with a bug. It doesn't have to be a big change or a large piece of work to try something new. In fact, you're more likely to succeed if you start small. Our content editor uses a setting system. The system is supposed to save some value for a user and load it back when required. It sounds trivial, but it did not always work. Users complained about having to continuously turn wireframe mode on when they opened our editor. They mentioned having to reselect layers and retoggle filters, and there were issues that could be worked around, but they were also issues that made our tools less transparent. Trying to debug the issues was a nightmare. They didn't always happen, and when they did, you would have to debug across multiple editors to see if the correct values were saved and loaded correctly. So instead of trying to spend time trying to debug our content editor to catch an issue in a standalone library, we wrote some tests for the library. And we started off simple. If I asked the system to save a setting, is it saved? If I asked the system to load a setting, is it loaded as expected? We tried this for different types to better understand what our system was doing, and we wrote tests first and saw where they failed. This gave us confidence that there was a bug in our code. We then changed the code to make our tests pass, and once we felt confident our code was doing the right thing because of our tests, we did some refactoring. Now, once we had our first few tests, we got more complex. For example, what happens if I load a setting that hadn't been saved? Trying out these different scenarios was now trivial and instant. We discovered a few things. Our system saved the setting key as a string, which meant that if we accidentally had duplicate strings, we would override certain settings. Our system also saved all settings to the same file. Again, if a setting got corrupt on read or write, it usually meant that the entire file became useless. Because we had the tests and we understood these issues, solving them was easy. We did not need to launch our editor to feel confident that our system worked. We needed to run our tests. Now, it's one thing talking about testing, but it's another to see them run, to see a bar turn green and tell you that your code does what you thought it would do. By starting small and taking initiative, we tried to solve something that we had identified as a problem. You don't need to be a lead, senior, or have written tests before. If you want to solve a problem, solve it. No one specifically asked us to write tests, and the person writing tests wasn't a lead. It was a member of the tools team taking initiative. Writing tests was a great opportunity to understand the process. We didn't know everything before we started, and we still don't know now that we had a few tests, but we knew enough to teach others. Our third step was to define standards. By standardizing the process, you will help others learn. In our case, developers liked what they saw, but they were still unsure what to test and how. Remember, testing is programming, and programming is a skill. It needs practice. Our standards focused on how we expect tests to be written, meaning which frameworks to use. We chose a set of standards that kept the barrier to entry low. I cannot stress this enough. If someone has to jump through hoops to try something new, something they are not keen on trying, they will not do it. This is applicable to anything. New workflows, new sports, new games. You're more likely to try a new game if it's in the store that you regularly use to buy games. You need to consider the workflow as a whole when designing a new process, not just what it will do. Yes, tests will prevent bugs, but how will they run? On what? And if they fail, how will we know? And how do they fit into your pipeline? We used MS Test, so our tools engineers could run tests within Visual Studio to get instant feedback. MS Test was built into the tools that we were already using. It is an industry standard framework which keeps barrier to entry low. It's great being able to test and to run tests locally, but we couldn't guarantee that everyone would run them locally. So we took a look at our continuous integration pipeline, which uses TeamCity. Engineers submit their work, and TeamCity runs jobs to compile and publish the tools, making them available for artists to use and download. Now, we added our tests to our continuous integration pipeline so we could guarantee they were being run. TeamCity already supports executing MS tests, and we added an additional build to our pipeline which ran our tests after compiling our code. It took minutes to set up, and the tests acted as a barrier, stopping bug-prone builds from being published, so artists only got access to the tools that we felt more confident about. We also created guidelines focused on what we should be testing. We took a pragmatic approach, focusing on testing new code and workflows to prevent bugs rather than adding tests to existing code to find bugs. This way, you will never write tests for the sake of it. If you know a feature is working, then there's no need to test it. It's when you want to change or extend this feature that the tests help. Now, there are many good books available that can help with standards and guidelines. Working Effectively with Legacy Code by Michael C. Feathers and Martin Fowler's online blog are excellent resources. So now we had standards and guidelines, which meant that more people were willing to try testing because their barrier to entry was low. But was it actually working? Was testing helping us feel more confident? We moved to the fourth step of our process: evaluate. We took the initial concerns that we had around testing. Our tools weren't designed for testing, and we don't have time to test. And we used these concerns to challenge our initial experiment. Did automated testing increase confidence and retain stability, or was it outweighed by our initial concerns? What had we achieved? We analyzed our feature and bug reports between expansions. We looked at the time spent fixing bugs and adding tests against the time spent adding new features with tests. In Forza Horizon 4 Fortune Island, 80% of a developer's time was spent on bugs. But in Forza Horizon 4 LEGO Speed Champions, after one cycle of adding tests, we already saw improvements. A tools developer spent 20% more time adding new features instead of fixing bugs over a 5-month development cycle. That's a whole month more of new features. Now, on average, a feature or bug took 30% longer to complete when adding tests. Shouldn't that have reduced our overall productivity? Well, we also noticed some less quantifiable things by adding tests, which I want to illustrate with an example. For our LEGO Speed Champions expansion, we had to build a snapping system that would allow our content creators to work within the LEGO rule set. LEGO can't intersect and had to stack and align perfectly with each other. LEGO can only be rotated in 90-degree increments when stacked. So we built the system from the ground up using a test-driven approach. Once again, we started simple. Given 2 LEGO we want to align, if a user moves one of the LEGO, is it automatically snapped into the correct place according to the rule set we defined? We wrote the tests first and saw them fail. If a test passes when there is no code to test, then something is probably wrong with your test. We wrote code until the tests passed, and then we refactored. One thing that was great about this system was that we discovered that there was a bug in a tools library that decomposed Euler angles. Once we fixed it, rotation and scaling became a lot smoother for our editor, and we'd have never caught this bug without this issue and without our tests. Now, unfortunately, because we wrote tests, it didn't mean we had written the correct system. There were scenarios that we missed and some we got wrong, and with each one we missed, bugs were raised and had to be fixed. But there were several advantages to having this system covered by automated tests. The first was that collaboration had improved, because understanding the snapping system was as straightforward as debugging the tests. Let's imagine someone had asked, what does the snapping system do if one of the LEGO is rotated on its side? Well, before you had tests, you would have to open your editor, place 2 new assets into your world, mess around until they were in the correct position, and then run the snapping system and see what happens. Did it look right, and was it snapping correctly? It probably didn't, so you'd zoom in and you'd have a look at what you've done, and something was wrong. Maybe you pressed something wrong. You weren't sure, so you'd try again. But now with tests, all we had to do was look at the list of test cases and find out what our system did when LEGO was rotated on its side. For the same reason, resolving bugs became easier. Once again, imagine someone raising a bug. There's a bug where snapping doesn't seem to work if the asset is already rotated. Now, instead of once again trying to set up your editor in the correct way to recreate the issue, You could write a new test for it and confirm there is a bug. And you would be confident the issue was fixed once the tests pass. But more importantly, you also know that you hadn't broken anything else. Now, my favorite part of writing tests was the release process of the snapping system. By the time QA and artists got their hands on it, it worked first time. There was no awkward bug fixing back and forth between the tools team, QA, and environment art. No nail biting as we anticipated the first crash bug the moment anyone but the tools team tried to use the system. Our tests covered those scenarios, and we had delivered something to our users that worked first time. So our conversations now focus on how we could make it better and not on the workarounds that they needed to make it run. And when we said that we were going to design our next feature in the same way and that it might take a little longer, they wanted us to, because they now trusted that we could deliver something that worked first time. So now that we'd evaluated and seen the benefits of testing, what was next? Did we convince everyone that testing was the right solution? Did everyone start writing tests because it seemed like a good idea? Absolutely not. And that's fine. Remember, it takes time. We decided to raise awareness once again about what we had done and see what others thought. Developers were more inclined to try testing when we focused on testing as a solution to a problem. But there were concerns that testing slows down work, and there were concerns that testing couples the code that it tests. So we did some more research and came up with two solutions. First, code written with testing in mind is different to code without. With testing in mind, you are forced to think about writing modular APIs that have well-defined inputs and outputs, so we can test them. If the API's implementation changes, but not what it does, then tests should not have to change. This meant that our snapping system, we could switch between Euler angles, quaternions, or matrices for our calculations without having to rewrite our tests. Secondly, we realized the importance of a testing mindset. Testing is a way of consistently ensuring that your workflows do what you expect them to do. If the API fundamentally changes, then the original tests for the API are no longer valid, and you would want new ones to ensure the API does what you now expect it to do. Yes, you could make a change and run your workflow once to make sure it works, but what about the next time and the time after that? A few more hours for an automated test when making a change does that for you. Now, we knew the concerns, so we updated our tests to focus on the public APIs of our snapping system rather than the method we used for calculation. We updated our standards, and we evaluated what we had done. By iterating on these 4 steps, we were able to cultivate a test-driven culture. We went from one person writing tests to the entire systems tools teams across 2 projects writing tests. It took us just under 10 months to reach 1,000 tests, and now, a year and a half later, we now have just under 4,000. If you iterate on these 4 steps, then you will be able to do the same. It doesn't need to be testing. It can be any new idea or process. Once people see benefits, buy-in becomes easier. Don't worry about not getting it right the first time. You won't. Learn from your mistakes and learn from ours. Creating a testing culture takes time. It is not a quick fix. Tests are only as good as the effort put into them. When our tests were wrong, our behavior was wrong, and it takes practice to get it right. Luckily, with the tests already written, fixing the issues is straightforward. But we learn to be humble about what tests can achieve. Remember that tests don't improve quality, developers do. Just because there's someone in the team that knows how to write tests and can prove they are helpful, it doesn't mean that everyone else is instantly on board. Developers need to practice writing tests. They need to practice testing key scenarios, and they need to accept that tests won't always prevent bugs. We want to make great, reliable tools so we can create even better games, and testing is another tool to help us get there. Write small, fast tests. If a test is taking minutes to run, that's minutes staring at a screen. Tests should be able to run hundreds of times a day. If you need longer running tests, then separate them from your fast tests. Make testing part of your estimates. If you include testing as a separate task, it will be cut. Testing adds 30% more time to a task without any testing, and a negligible amount to tasks in areas of code that are tested. Remember, testing also saves time in the long run. If it takes QA 30 minutes to test a workflow manually, it quickly adds up. 30 minutes per workflow in a 7.5-hour day is 15 workflows. So, if there are 16 workflows, it would take a day before something is tested. Keep tests as deterministic as possible. If your test relies on many systems, file systems, databases, random numbers, then there's more chance something will go wrong. And failures that sometimes happen are frustrating and reduce confidence in tests. But consider a workflow for tests that sometimes fail, especially as you are learning. You don't necessarily want to wait for a build to run again. That lowers the value of your tests, and you need a way of quickly muting these flaky tests until they can be fixed. TeamCity supports this out of the box. By not making the same mistakes and learning from ours, you can make your testing journey much smoother. As we continue on our journey, here are a few things that we are looking to do. We've created a studio-wide testing group. The goal is to answer the question, how do we be more confident that our changes work and retain stability across all disciplines, not just tools? We send monthly updates, we run workshops, and we provide help. It's the next evolution of our initial culture shift iteration. We also want to automate some of our manual tests. This is not easy, but the testing mindset is helping. If we design our tools such that the UI is separate from the underlying business logic, then we can write tests where the test itself mimics the UI. This way, we speed up our release process and can also debug what our code is doing. We plan on using past failures and bugs to help focus where to spend more time testing. If you are under time pressure and you want to focus your testing efforts in areas of code that are changing most often, a tool like SonarQube can help identify these areas. What about you? What are your next steps? Well, I challenge you to find the problem that you are passionate about and want to solve. It might be stability, it might not be. Don't ask for permission. Take the 4 steps that you've heard today, raise awareness, decide and implement, define standards and evaluate, and try to solve it. Introduce positive change into your studios. And once you have, come to GDC and tell us about it. Today, I've shared how Playground Games has improved the stability of its toolset and increased developer confidence by adopting a test-driven approach to tools development. I've taken you on our journey from 0 to over 1,000 automated tools tests and beyond. You know how a test-driven culture has increased the time that we spend on features, reduced bugs, and improved collaboration, made resolving bugs easier, and increased trust with other teams. You know how to help your teams cultivate a test-driven approach, and that it is an iterative process and no quick fix. You know some of the pitfalls that we made so you can learn from our mistakes, and you have been challenged to introduce positive change. I'm David Paris, Senior Tools Engineer at Playground Games and Chairman of the Testing Working Group. I hope you found this talk insightful and interesting. And if there are any questions or comments that you have, please feel free to reach out to me over Twitter at DavidJPParis. Thank you for your time.